Today we're going to look at section 3.6a, matrix multiplication. Our objective today is to be able to multiply matrices and more specifically multiply by hand. So what must be true in order to multiply matrices? Well, the column of the first matrix must be the same value or unit as the row of the second matrix. It's a little bit more complicated than what we had to do with addition and subtraction. So what that means is if my first matrix is a 2 by 3, my second matrix must be 3 by something. So let's say, for example, 3 by 1. Therefore, the row of the second and the column of the first are equal. I could do lots of different things. If I had, say, a 4 by 5, the next one could be a 5 by 7. Anything like that, as long as the column of the first is equal to the row of the second. So what is that going to actually look like? So here are two different matrices, kind of give you an example of what actually happens. This first one is it has an order of 1, 2, 3, 4 rows by 1, 2 columns. B has 2 rows by 3 columns. So if you look, the number of columns matches up with the number of rows. So what is our answer going to look like? Well, the product has an order equal to the row of the first matrix by the column of the second. So if you look at our answer, okay, the 2's match up, so we're left with a 4 by 3. 1, 2, 3, 4 by 1, 2, 3. Okay. So how this works is to find our solution, we use the rows of our first matrix, that's where the 4 comes from, and we look at the columns of our second matrix, and that's where the 3 comes from. And we use a combination of those to get our solutions. So we're going to go through a couple of examples so you can see what that looks like. So in our first example, always what you want to do first before trying to do any of the math is to find out the order. So this is 2 rows by 1, 2, 3 columns. This is 1, 2, 3 rows by 1 column. Because these are the same values, and we don't have to worry about units in this kind of problem. When we get to word problems, we worry about the units. But when we're just doing a generic matrix, we're assuming these are the same units. We're just talking about numbers. So what this tells me is my solution is going to be a 2 by 1 matrix, which means it has 2 rows and only 1 column. So all of this is going to boil down to give me a solution that looks like this. So how do we go about this? Well, what I want to do is figure out this answer right here. Okay, if I look at this answer, this is in row 1, column 1. We get our rows from our first matrix, our columns from our second matrix. So we have to use these numbers to come up with one answer right here. So let's think about how that we're going to do that. What we do is actually take each entry and multiply it by its corresponding entry. This is the first entry in the row. This is the first entry in the column. Okay, so I'm going to take 5 and multiply it by -4. Plus, now I'm going to take the second entry in the row and multiply by the second entry in the column. 4 times 6. Plus the third entry in the row times the third entry in the column. So I get 7 times 7. So this would be -20 plus 24 plus 49. If you remember from our order operations, we add left to right, so -20 plus 24 is 4. 4 plus 49 gives me a 53. So this, sorry about that, should be a 53. Okay, so let me erase that for you. Okay, should be a 53. So it's going to write in a 53 here. 53. Okay, so how do I get the next number? Well, I'm going to do the same thing. I'm going to look at, this is row 2, column 1. So all I'm going to do is shift this down, okay, to my second row. Those are all linked together, of course. Okay, so let's erase this to make it a little bit easier. Okay, so now I'm going to look at row 2, column 1. And I'm going to do the same thing. Take the first entry times the first entry of the column plus entry 2 is 1 times the 6 plus 0 times 7. So this is going to give me a positive 12 plus 6 plus 0, which is a total of 18. Okay, and that's how we get our solutions. Then you have to remember it's row times column and always match up the entries. And that's why it's so important that these are equal, because this stands for the number of columns. There's 3 here, and this is a number of rows, 3. So that's why I know there's the correct number of numbers in this matrix that will match up with the entries in the second matrix. Let's try this again. So this is a 1 row by 4 column. This is a 4 column by 2 row. Again, these match up. So now my solution is going to be 1 row by 2 columns. So 1 row by 2 columns. Okay, so I'm going to show you a couple different ways that you can write out how to get this. Remember, we take the rows from here. There's only 1 row here. And these are column 1, column 2. And that's why this is a 1 by 2. Here's my 1 row, and here are my 2 columns. This is row 1, column 1, so I'm going to look at row 1 and column 1. If it helps you, sometimes I like to just take the row, 6 times something, minus 2 times something, negative 5 times something, and a positive 9 times something. What goes in here are the values in column 1. 0, 1, 7, negative 3. Sometimes that might be easier to help you make sure you multiply the correct ones. The first times the first, second times the second. Now I'm just going to do the algebra. 0 minus 2 minus 35 minus 27. Again, I'm going to add left to right. I don't have to worry about the 0. This gives me a negative 37 minus 27. Both are negative, so I'm going to add the 2. So I'm going to get a total of a negative 64. Okay. So in row 1, column 1, I'm going to put a negative 64. Let's try the second part. I'm going to write it down here. I'm going to choose a different color. So now again, I'm going to do the same thing. I only have 1 row in column 2, so I'm going to do the same thing. I have 6 times something, a negative 2 times something, a negative 5 times something, and then a positive 9 times something. What goes in here is column 2. So I have a 5, a negative 4, a 3, and a 2. 6 times 5 is 30. Then I get a positive 8, a negative 15, and a positive 18. Add left to right, I get 38 minus 15 plus 18. If I subtract 38 minus 15, it's going to give me a 23 plus 18, which gives me an answer of 41. And I get a 41 right here. And that's how you multiply those two matrices together. Okay, let's try another one. So the first thing we want to do is look at the order. This is a 2 by 3, and this is a 3 by 3. These are the same, so my solution is going to be 2 rows by 3 columns. So 2 rows, but I have 3 columns. And I find it's always easier to put these dashed lines so I fill it in so I know I don't miss anything. This one I'm going to do in a little bit different order, just to see if you can come up with how to get it. So let's say I wanted to find this one first. Okay, so what am I going to do to find that value? Well, first I need to think about what row and what column it is in. This is in row 2, because this is row 1. And then we have column 1, column 2, column 3. So to find this value, I need to look at row 2 and column 2. So if I go over to my matrices, I get my rows from this one. Okay, and then I get my columns here. So row 1 and column 2. So I'm going to go back and do the algebra. I know I need a 3, a negative 4, and a 0. And this is a positive. We'll just put plus 0. Always want to vary a sign, a plus or minus, except for the front. And then I'm going to substitute in 1, 8, and 9, because it's 3 times 1, negative 4 times 8, 0 times 9. This gives me a 3 minus 24 plus 0. And this gives me a negative 21. So I put in negative 21 right here. Okay, let's try to do a different one. Okay, try to find this out. And if you want at any time, you can pause the video and see if you can figure it out on your own. So right now I'm going to go through how to get row 1, column 3. So row 1, 8 plus 1 minus 2. But now I have to look at, okay, and again I got that all from row 1, and now I'm going to look at column 3. If I look at column 3, I'm going to substitute a 3, a negative 2, and a 1. So I get 24 minus 2 minus 2. Go left to right, I get 22 minus 2, which is a 20. And here I get a 20. Okay. In a second, I'm going to just have all the other values appear. If you would like to right now, you could pause the video and see if you can find the other 4 missing values, and then you can check it in a second. So if you want, pause now. As you can see, all the other entries have now been added in. You should get a negative 12 for row 1, column 1, negative 2 for row 1, column 2, a negative 22 for row 2, column 1, and a positive 17 for row 2, column 3. Okay. All right, so let's try one more. Again, if you'd like to pause to kind of see the solutions here, I'm going to go through this one a little bit faster. This is a 2 by 2, and this is a 2 by 1. Okay, these are the same, so my final answer is going to be 2 rows by 1 column. To find the first one, I'm going to take row 1 and column 1. So I'm going to get 7 times negative 2 is a negative 14. 1 times 4 is a 4. My answer is a negative 10. And that's how you could do it without showing the work. But if you struggle at all, I would show the work. This one is row 2, column 1. This would be negative 6 times negative 2, which is a positive 12. Negative 8 times 4 is a negative 32, which would give me an answer of a negative 20. And that would be my solution. Our last example is similar to what we did the last lesson, and you're solving for x and y. It is much more difficult to find x and y when multiplying matrices than it is for adding and subtracting, because most students forget about the rule of row times column, especially when I give them square matrices. So this is a 2 by 2, a 2 by 2. These are the same, and therefore my solution is a 2 by 2. But we're multiplying, so you can't just take entry times entry equals entry. That will never be the correct way to do it. We want to do row times column. So I'm going to first look at the x's. The x is in row 2. And remember, the reason I'm picking row 2 and at column 2 is because the first matrix, we always look at the rows. Now, if I look at my solution, if I take row 2, and if I take column 1, I'm going to get a 3. If I take row 2 and column 2, I'm going to get a negative 93. It doesn't matter which one you look at, but I think 3 is a much easier answer to look at than negative 93. So to get this one, row 1, column 2, I'm going to look at row 1. I'm sorry, row 1, column 1. It's going to be row 2, column 1 to get this entry. So what does the rule tell me to do that we've been working on? I'm going to take 6 times the first entry plus 5x times the second entry, and that should equal my solution. 48 minus 15x equals 3. I'm going to subtract 48 from both sides. If I subtract 48, I get negative 45. Divide both sides by negative 15, and I get a positive 3. Okay? And you can always substitute this back in and then do the algebra yourself again to make sure it works. All right, so now I need to figure out y. Okay, so let's move this. Here's y. Y happens to be a solution, so I know how I get this. This is row 1 and column 1. So if I move this up, row 1, column 1 should give me my solution. So I'm going to take 5 times 8 minus 2, or negative 2, times a negative 3 should give me my solution of y. This is 40 plus 6 equals y. Therefore, 46 is equal to y. I hope you feel a little bit better about matrix multiplication, especially when doing it by hand. In future lessons, I will show you how to use the calculator to manipulate, but you will be expected to know how to do this by